All right, welcome to Unit 3. We are going to start by classifying triangles today. So in this first unit, hopefully you will see some words or hear some words that you're familiar with. And this is a little bit of review before we get into some new stuff in the rest of the unit. So Unit 3, triangle properties, starting with classifying triangles. So first, we probably just need to make sure we're all clear on what a triangle is. So three non-collinear points, that would be D, E, and F in this case. We have three angles or three vertices, and we name our triangle by those vertices. So if I was going to name this triangle, it would be triangle DEF, or some combination of those three letters. It doesn't have to be in that order. Just again, triangle, we have three sides and we have three angles. Okay, so three angles are vertices, three sides. When we classify triangles, we can classify them based on either their angles or their sides. So if we first look at classifying by sides, that's what these words are. Okay, the first one would be scalene. So I'm going to draw these pictures. Forgive me if they're not perfect. Oops, I don't want the highlighter. Okay, so scalene could look something like this. And the important thing here is that we have no congruent sides, meaning there's no markings or there's no measurements that are the same throughout the entire triangle. Okay, isosceles, you're going to have two congruent sides. So again, remember, congruent just means the same. So we have two sides that are the same length, or they have those tick marks on there to show that they're congruent. And then equilateral, again, hopefully this is a word that maybe you've heard before. All three of these sides are going to be the same. Okay, so if we're talking about sides, we have scalene, which is no congruent sides. We have isosceles, which is two congruent sides. And we have equilateral, which is three congruent sides. We can also classify our triangles by their angles. Okay, so first type would be acute. And all three in this situation, they're not going to be the same, but they are going to have three acute angles. And just a reminder, acute is less than 90 degrees. Okay, so all three angles in that triangle are going to be smaller than 90 degrees. We could have an obtuse triangle, which could look something like this, where we have one obtuse angle. Why do we only have one obtuse angle, whereas before we had three acute angles? Well, the angles in a triangle have to equal 180 degrees, right? So if I have one obtuse angle which is more than 90, right, because that's what obtuse means, it's greater than, oops, wrong way, greater than 90 degrees. That means that, let's say that this is 100 degrees. Well, if I take 100 away from 80, there's only 80 degrees left, right? Meaning those two angles would have to add up to 80 together. There's no way that they could be obtuse. So because all three angles in a triangle have to add up to 180, when we have one obtuse angle, that's all we can have. Okay, so we just need to see that one, and then we know it's obtuse. Same thing with a right triangle. You are just going to have one right angle. Okay, and for the same reason, because once we take away 90 from 180, we only have 90 left, and we have to split that into two angles. So if we're classifying by angles, we have acute, obtuse, or right. Okay, so let's do a couple examples here. All right, first one, let's look at angles. So I have a 45-degree angle, a 45-degree angle, and a 90-degree angle. Well, as soon as I see that 90-degree angle, I know that that has to be a right triangle. Again, one right angle, and we classify it as a right triangle. When I'm looking at sides, I see these two tick marks. I don't see that on the third side, so that tells me I have two congruent sides, which means that this is isosceles. Okay, so that would be a right isosceles triangle. All right, if I look at the next one, if I'm looking at angles, I see a 60, a 60, and a 60. Well, those are all the same, but they're also all acute. So this would be an acute triangle. If I'm looking at sides, I see one tick mark, two tick mark, three tick marks. That tells us all three are congruent. That means it's equilateral. Okay, another word that you might see for this type of triangle, it does have to do more with the angles, would be equiangular. Okay, equa meaning the same, equal, right? Angular referring to the angles. So we could call this equilateral and equiangular because the sides and angles are all equal. All right, next one, if we look at angles, we have a 54, a 54, and a 54. Those are the same. The 72 is different, but what I know about all three of them is that all three are acute, making that an acute triangle. When I look at the sides, I see a 4-inch and a 4-inch. That 5-inch is different, so again, two congruent sides, that's isosceles. So that would be an acute isosceles triangle. Last one, okay, I'm looking at angles. None of them are the same. This one is large, right? That's greater than 90, so that means it is obtuse. One obtuse angle makes it an obtuse triangle. And if I look at sides, I have a 6-inch, a 9-inch, and a 14.5-inch. They're all different. That means that is scalene. All three sides are different. None are congruent. The last thing we might see in this unit is a problem like this. Okay, this says the perimeter of GHI is 21 units. Perimeter just meaning distance around a shape. Right, so if I were to add all three sides, that's how I would find the perimeter. So I'm going to use that to my advantage, right? If I would take GH plus HI plus IG, right, that would give me the perimeter because I'm adding all three sides together. So now we're just going to substitute in what we know. So GH is x plus 3, HI is 8, IG is x plus 4, and it told us that the perimeter is 21. Okay, so let's draw our line down the middle and figure out how to solve this. I have x's on both sides. When they're on the same side, I add them together. So x plus x is 2x. Same thing with my 3, my 8, and my 4. They are all on the same side, so I'm going to add them together. 3 plus 8 is 11, plus 4 is 15, and that equals 21. Subtract the 15, so I get 2x equals 6. Divide by 2, and x equals 3. Now, it's important, it says find the missing sides. It doesn't say to solve for x. So I need to take that x, plug it in back up here. So 3 plus 3, this side is 6. 3 plus 4, this side is 7. There you go. Now we're done. The rest of these notes are just going to be extra examples. We will go through some of these in more detail in class tomorrow, but if you want to give them a try on your own, they're here for you. And if not, I will see you in class tomorrow.